Hi guys. Welcome back. Today I don't really have much to say to start as usual. We're talking more, as you can see, about solving quadratic equations by taking square roots. So this is again coming from section 8.7. So there's not much new in terms of like how to do any of these problems. It's pretty much the exact same thing that we've talked about up to this point. It's just going to be some slightly more complicated numbers. Actually, I think I might have to take that back. Whatever. At least to start out with, none of this is new. All right. We're solving the equation. It does also give us the specification that your final answer should not contain any decimals. And that's going to be important in a minute, and I think you'll see why. The idea is the same kind of thing we were talking about on Monday, where we want that quadratic term, the whatever you're squaring, isolated first. So we're going to have to get rid of this minus 60 on both sides by adding 60. So x squared is 60. And now that we have this, we are able to take the square root of both sides. The problem becomes then, when you actually take the square root of 60, if you weren't 100% sure what that was, it gets you this horrible decimal. 60 is not anywhere on this list of perfect squares. So if we're not allowed to use decimals, how do we write this? We could absolutely just say the square root of 60, or we could simplify that radical, all right? Because the square root of 60 might not be the simplest form of the square root of 60. So we can try simplifying that radical. And in case you don't remember how to do that, I'm going to go back to this perfect squares sheet. Where would 60 fall in between? Where would 60 fall on this list? It would be in between 49 and 64. So the question we're asking ourselves when we do this is, what is the smallest perfect square? What is the biggest perfect square that's smaller than 60? And the answer here is 49. So we're going to do 60 divided by 49. Didn't think it was going to work. And we're just going to keep going smaller and smaller until we find a perfect square factor of 60. So I think I know what it's going to be already, but I'm going to go through the whole thing just to show you guys. If you don't remember me saying this last time, if you already know that 60 isn't going to be divisible by 25, you don't have to check it yourself in the calculator. It's just for all that procedural stuff. Yeah, 60 divided by 4 is 15. 4 is the only perfect square factor of 60. Aside from 1, but that doesn't change anything. So 60 simplifies into 4 and 15. So square root of 60 breaks down into the square root of 4 and the square root of 15. Which one of those is the perfect square? It's 4. And what's the square root of 4? 2. We can't do anything with the square root of 15. So we're just going to leave it as the square root of 15. Excuse me. And there you go. The only thing we have to add on now that we're actually solving these quadratic equations is, because we actually are evaluating square roots, we can't forget about the positive or negative that we talked about the last time we did this. So x equals plus or minus 2 times the square root of 15, or 2 root 15. And there's that problem. We solved it. We got x by itself. We don't have any decimals. We're good. All right. So, same kind of thing that we just did. We want x squared alone first. So plus 64 divided by 2. And now that we have x squared alone, we can continue with this problem, because we're not done yet, by taking the square root of both sides. And again, 32 isn't a perfect square, so we're going to have to, again, not evaluate it and get this horrible decimal, but we're going to simplify the square root of 32. Where does 32 fall on this list? In between 25 and 36. So we're going to start out with 32 divided by 25. Didn't think that was going to work, but 32 divided by 16 is 2. So simplifying this in one go, again, the reason why we're simplifying radicals this way is so we can simplify it in one step instead of breaking everything down multiple times. So we can break the square root of 32 down into the square root of 16 and the square root of 2. 16 is your perfect square. That's 4. 2 isn't a perfect square. It doesn't have any other factors that are a perfect square. So we're just going to leave it as square root of 2. Don't forget plus minus, and we're done. Okay. All right. The squared term is actually whatever's in parentheses. You know, there's nothing outside of the square that we need to worry about. So in this case, we are actually able to take the square root of both sides right away. And 19 is, again, not a perfect square. That's the whole point of all this. 19 goes in between 16 and 25. So we're going to start out dividing 19 by 16. And I mean, I hope a lot of you kind of thought this way. 19 isn't divisible by anything or any perfect squares. You know, so it's impossible to simplify the square root of 19. That doesn't mean there's no solution. It's just that we're going to have to leave it the square root of 19. And again, because we're solving quadratic equations, you still need the plus minus. The square root and the squared cancels out. So we're left with x plus 3 equals plus minus the square root of 19. Now, here's the nice thing, all right? In this case, when you have radicals, right, we know we're going to eventually have to split this up into two separate equations and subtract 3 from both sides. But square root of 19 is going to get you a really ugly decimal, and we don't want that. So is it possible to, when you end up subtracting 3 from both sides, is it possible to do 19 minus 3 is 16? No, that's not, that you're not allowed to do that, all right? If I did split this up into positive square root of 19 and negative square root of 19, when you subtract 3 from both sides, regardless, you can't do this. If one number has a radical above it and the other one doesn't, you have to keep them separate, all right? Like something like x equals the square root of 19 minus 3, or negative 3 plus the square root of 19. As long as you're careful with the signs, the order doesn't really matter, all right? So if you're doing the same thing over here, this would just be negative 3 minus the square root of 19. And it's a really terrible looking answer, but it is an answer. You know, if you evaluated both of these in your calculator, you would get numbers, you know? So these are both your answers. Now here's why I had said this is the nice thing like a minute ago. If I go back to the original plus minus the square root of 19, look at these answers that we had gotten. The numbers are exactly the same. The negative 3, the square root of 19, one is a positive, one is a negative. So to make your life a little bit simpler in this case, when you subtract 3 from both sides, you can just do it right away and kind of put it in front. Oops, you can't see it. There we go. Put it in front like I have for these two cases. So you can write it as negative 3 plus or minus the square root of 19. If you use like Khan Academy or look up internet articles for things like this, I feel like most places might give you an answer that looks like this. But technically speaking, everything here is correct, all right? And it does follow the instructions. Your final answer should not contain any decimals. We don't have any decimals. That's why we're leaving the square root of 19 as is, and we're just kind of tacking on the minus 3 along with it. You know what I mean? So same kind of thing, all right? There's nothing to get rid of on the outside. So we're just going to take the square root of both sides. I think the square root of 88 you are able to simplify. 88 is between 81 and 100, so we're going to start out with 88 divided by 81, which is probably not going to be it. And I'm just going to keep going. Okay, there it is, 4 and 22. So square root of 88 breaks down into the square root of 4 and the square root of 22. 4 is your perfect square. It's 2. We can't continue with 22. We did this all in one go, so we're going to leave it as the square root of 22. Don't forget your plus minus. This up here cancels out. And so we have x plus 7 is equal to plus or minus 2 root 22. And again, we're not done yet because we don't have x completely isolated. So you could split this up if you want to, but again, for this is mostly like for the sake of time, why I'm just kind of doing this. And also sort of for the sake of organization, because -7 plus or minus 2 root 22 in the math world looks a whole lot nicer than having your two solutions separate. So there you go for that one. Okay? All right, this is kind of why I had taken back me saying we're not doing anything new. Because I do also want to throw into this idea of rationalizing. So in the math world, as it says, you are not allowed to have a radical in the denominator of a fraction. It is not pretty math, which means it is not allowed. And if we do ever have any sort of assessment on this, or even when I do check your assignments, I will be taking points off if you leave any radicals in the denominator because it is not allowed. So how do we get around this? We do this thing called rationalizing. All right. And it's a pretty simple explanation that I have here. To do this, we multiply the top and the bottom of the fraction by whatever radical is in your denominator. So if this was the problem, right, 5 over root 2, and it said simplify or rationalize or something like that, the way you would do this is you would multiply both the numerator and the denominator by the square root of 2. All right. So the numerator works similarly to what I had said before, where if you have a number with a radical and then a number without a radical, you can't do anything with them together. You have to keep them separate. So 5 times the square root of 2 is not the square root of 10. All right? It's just 5 root 2. Okay? With the denominators, though, you are allowed to do, in this case, you are allowed to do 2 times 2 because they both have a radical. It's sort of like a like term situation. You know, x and x are like terms, so you can combine them. X and y are not like terms, so you wouldn't be able to combine them. You're only allowed to work with numbers that either both have a radical over them or both don't. So since root 2 and root 2 both have radicals, you are allowed to multiply the numbers together and then put it under another radical. So root 2 times root 2 is root 4. Okay? And we know what the square root of 4 is. That's the whole reason why we're doing this. The square root of 4 is 2. All right? So this is 5 root 2 over 2. This would be your final answer for a question like this. All right? And you can still, like, if you have 5 over 2 on the outside, you can definitely try to simplify that fraction with the coefficients on the outside. In this case, it's not possible. It's not always going to be possible, but again, you can definitely try. So this is a very similar example where we want to simplify this. We don't want this radical in the denominator anymore. So we're going to multiply both pieces of the fraction by the square root of 5. 2 times root 5, again, they both don't have a radical over them. One has a radical, one doesn't. Excuse me. So we're going to leave this as 2 root 5. root 5 and root 5 do both have a radical over them. So in the denominator is going to be the square root of whatever 5 times 5 is, which is 25. And we know what this evaluates to. The square root of 25 is 5. So this is 2 root 5 over 5. And same kind of thing like with the 5s, right? You cannot say 5 over 5 is 1 because this is root 5 over 5. All right? Root 5 over 5 is not 1. Do not do that. Okay? We are going to leave it as 2 root 5 over 5. Okay? And the other thing I want to mention is if you noticed with the last one, we had over root 2, and our final answer was over 2. We had over root 5, and our final answer was 5. That's the whole reason why this works. All right? If it makes a lot more sense to you to put it over the square root of 25 and then evaluate it, that's absolutely fine. I'm showing this to you because this is the first time most of you have probably ever seen anything like this. If you are aware or have enough number sense to realize root 5 times root 5 is just going to get me 5, you can easily skip this part and go right to here. All right? But again, it's whatever makes the most sense to you. Okay? So, there are 2 different ways you could do this problem. All right? We're going to start out rationalizing it. All right? So, we're going to multiply by root 10. So, we have the square root of 2 times 10, which is 20 over 10. Okay, root 10 times root 10 is the square root of 100, and the square root of 100 is 10. I'm getting close to the 20-minute mark, so I'm trying to save a little bit of time. Now, the other thing with radicals in general is that you always have to simplify, if possible, whenever possible. All right, so before you wrap up these kinds of radical problems, you always want to make sure any radicals you have can't be simplified anymore. So we want to double check that the square root of 20 can't be simplified. And 20 is like sort of a big number. It would go in between 16 and 25. So I'm just going to do those really quick. 20 divided by 16. And there you go. 20 is divisible by 4, which I'm sure most of you guys were able to pick up on. The square root of 20 can be simplified. It can be simplified into root 4 and root 5. 4 is your perfect square. So the square root of 20 is going to be 2 root 5. Okay? Over 10. Now again, we're only able to work with like terms. You know, things that both have a radical, things that both do not have a radical. So 2 and 10, 2 over 10, are we able to reduce that fraction as we see it? Yeah, we are. All right. 2 over 10, if we were just looking at that as a fraction, you could reduce that to 1/5. So this is going to be 1 root 5 over 5. And since 1 times anything is just that anything, you could even simplify this down further to say root 5 over 5. This is the most simplified, and it is the most mathematically precise. This I would probably accept on homework, quizzes, etc. This I definitely would not, because you can reduce the 2 over 10, and neither would I accept this. All right, that's method number 1 for this problem. Method number 2, I personally think, is faster, but again, it's whatever makes more sense to you. So we're going to go back to root 2 over root 10. It kind of goes back to the whole idea I was saying with the 2 over 10 here. You can work with them because they both do not have a radical. These both do have a radical, so you can simplify this fraction. You can simplify 2 over 10 and then put radicals back on both numbers. So 2 over 10 would reduce exactly the same way we just did it. It'd be 1 over 5. So it would be root 1 over root 5. 1 is a perfect square that a lot of people forget about. It's 1. So the square root of 1 simplifies to 1 over root 5. It's still not done yet because you have a radical in the denominator, but you can just rationalize the same way we just did, times root 5. And then 1 times root 5 is just root 5 over root 5 times root 5 is root 25, and then the square root of 25 is 5. Same thing as before. Do not say root 5 over 5 is 1 or root 1 or anything like that. All right? They are not like terms. One has a radical, one doesn't. You have to keep them separate. But we did get the exact same thing that we did before. So again, these are two different methods to do the exact same problem. And you have the choice. All right? It's whichever one you're most comfortable with. All right? So how does all of that come into solving quadratic equations by taking square roots? Well, all the way back to the beginning, we want n squared alone first. So we're going to do the same things we did at the beginning of this lesson. Plus 9 divide by 5. Now this also says your final answer should not contain any decimals. So we're going to keep that pattern up as we do this problem. And I'm not going to have any decimals through at all. So n squared, I'm going to leave this as a fraction, 49 over 5. Okay? Now we can go in and take the square root of everything. And I think I mentioned this last time. When you take the square root of a fraction, you are allowed to take the square root of the pieces. So the square root of 49 over the square root of 5. I'm going to move up here. We know what the square root of 49 is, or we should. It's 7. So don't forget about your plus minus. Plus minus 7 over the square root of 5. Now, I wanted to mention the radical business because this is not done yet. This is not pretty. Okay? You cannot have a radical in the denominator, so you have to rationalize like we did before. That's how everything is coming together. Times the top and the bottom by root 5. 7 times root 5, you're leaving as 7 root 5. Root 5 times root 5 is root 25, which is 5. Don't forget your plus minus and equals. And that's that problem. Okay? All right. Let's go. Plus 1. Okay. That's the easy part. Now, when you take the square root of both sides, again, this is root 99 over root 7. So, can the square root of 99 simplify? Yeah, I'm pretty sure it can. 99, I mean, I already know. Yeah, I'm over 20 minutes at this point. 99, well, actually, let's just go through it. 99 is between 81 and 100. So we're going to start with 99 divided by 81. And what I was saying before was like, I think I already know what 99 is divisible by. But, oopsie. Just for the sake of consistency. Yeah, that's what I thought. 99 is divisible by 9. So the square root of 99 breaks down into the square root of 9 and the square root of 11. So this is plus minus, the square root of 9 is 3 root 11 over root 7. Not done yet because we have a radical in the denominator, so we have to rationalize by multiplying by root 7. Now, in terms of this, again, I keep saying this, we're only able to combine the pieces that either both have a radical or both don't. So what are we multiplying 7 by? we're multiplying it by 11 because that's the number that has the radical over it. All right, along with the 7. So this is 3 root 11 times 7 is 77. 7 times 7 is 49. Square root of 49 is 7. Plus minus. Really quick, I don't think the square root of 77 can be simplified, but I am going to double check because I'm honestly not sure. Which you should too. 77 is in between 64 and 81, so we're going to start out with 77 divided by 64. And move on down the line. Nope, 77 divided by 25. No, 4. Yeah, I didn't think so. I didn't think 77 was going to be divisible by anything, so we got lucky. We are able to leave it as the square root of 77 and equals that whole mess. All right. I don't know how many problems you're going to get like this that are this complicated, but I do just want to show you because there are going to be a lot of instances when you guys take geometry next year where you are going to have to deal with this idea of rationalizing. Probably, hopefully not this complicated, but I just want to make sure you're aware of it. So when you see it next year in geometry, you don't like freak out, you know? All right. But you're more than welcome to reach out if you have any questions. There's the big hangout that's still active, the question forum. You're more than welcome to sign up for a video conference if you need to. I would try to like do it ahead of time. You know, like if you want to do like a 12 o'clock conference, don't put your name on the list at 11:30. But yeah, I think that's everything I have to say for today. This might be my longest lesson, almost half an hour. All right. Yeah, that's it. Talk to you guys soon.